Okay, welcome back. In this video, we're going to be looking at absolute values. So video C11, and again, specifically looking at absolute values as a distance and a reflection. Concepts that you've seen distance before, and you'll see reflection more next year. So our learning goal you can see is similar to other videos. We're going to look for internal structure. So if we see a function y equals absolute value of f of x, we're going to look at what that inside function is, kind of use our skills on the inside function, and then build up the whole absolute value function. So you can see the hook there. Our hook today is if we have f of x equals -3, what is the absolute value of f of x? And then follow-up question is, does that change the input or only the output? Or does it change the output? What does it change? So take a minute to think about that, and then we will kind of pretty quickly come back for it in the I do one here. So diving into I do one, just kind of pull it up, try to get all there. Okay. So I do one says, all right, if we know function y equals x minus 3, that's an easy line, right? Slope of 1, intercept of -3. Let's use that and to look at eventually the absolute value of x minus 3. And then we're going to stay intercepts domain range and just kind of dive in. So our prompt here is we're not going to take the absolute value of the input back from the hook. The only thing the absolute value does is the output. So our question is, if that output y value is already positive, do we need to do anything with it? So let's take a look. So as I kind of build this one up, f of x equals x minus 3. If I plug in inputs from 0 to 6, again, I know it's just a line. So if I plug in 0, I'm going to get 0 minus 3 is -3. If I plug in 1, I get -2, -1, 0, 1, 2, 3. Not interested, or not very interested anyway. Output. So our question was, if the y value is positive, does it need to be reflected? Well, we know if it's negative, it will be reflected, right? So at -3, if I'm taking an absolute value, will become +3, +2, +1. Now, absolute value is the distance. So if it's already positive, to come back to the question I just posed, we do not have to flip a positive output, right? This thing isn't like a negative sign. It's not flipping every sign. It's just going to turn negatives into positives. So 0, the 0.3 output of 0 remains 0. Output of 1 remains 1. Output of 2 remains 2. Output of 3 remains 3. So there is absolute value of f of x. So we kind of have all our points. What we can do now is we could go ahead and sketch this thing. So if I went ahead and sketched it, I might, maybe I'll go in green for f of x. So green for f of x. So f of x is, again, just that line. So I'm going to say, well, I know the point 3, 0. So 3 zeros there. And then from there, just a slope of 1. So points like that and like that. And I can connect the dots like so. And this gives me f of x equals x minus 3. So again, recognizing that internal structure, that's just a line which we've seen in Math 10. Perfect. Okay, so what about the absolute value? Well, we can see for the absolute value for this portion, for the root, the x-intercept to the right, everything's the same. So for here, for my absolute value, I know from here, I do have the exact same graph. Okay, but we reflect any negative values. So if I kind of grab this, let's go another color. These colors here are going to get flipped over. So, and each of those is going to be, I'm just going to flip it up here. So I'm going to go, instead of, so this was the point, change colors here. That was 2, -1. 2, -1 becomes 2, +1. 1, -2 becomes 1, +2. And then the intercept, another interesting point. So 0, -3 becomes, so keep the input, flip the output. So that's going to become 0, 3. And I connect those dots. And that kind of creates, it's going to look like another piece of a line. It's kind of like the alter ego here. It's like that. Now, if I look at it all together, so in blue here, I have color coded this. I could say it a couple ways, but this is, it's really, so g of x equals absolute value f of x. We'll fix that bracket. Absolute value f of x, or absolute value x minus 3 being more specific. So yeah, we could see kind of that V shape, and what you could do is really, if I wanted to just see the absolute value, is I would not actually have that part below the axis. It would look like that kind of V shape. Again, it's created, it looks like two different pieces, but it's just, where is the original function positive, keep it, where is it negative, flip it upside down. So answering a couple questions here about those. So we kind of talked it through, but what stays? So those yellow parts stay. So the yellow parts stay. So anything x is 0 to infinity. Now the 0, I do have to include the intercept somewhere. I like to keep it on the stay side like this. What reflects? It's going to be, or sorry, that wasn't, no, not outputs. Sorry, input was 3. So I'm going to keep 3 and up. And again, I'll include the 3. So what reflects was everything else. So everything on the left side. So negative infinity all the way up to 3. Now, because I included 3 in my stay part, I'm going to disclude it from my reflect part. Intercepts, I can see them there. So my intercepts, I'm looking at the absolute value. So this is the kind of g of x question, which is absolute value f of x. So my intercepts here are going to be, I can see my y-intercept is 0, 3, and my x-intercept is 3, 0. My domain, unrestricted, so domain is going to be the real numbers, and my range is just going to say, well, you can't be negative because the absolute value would have flipped the negative, so 0 until infinity, and that's it. So again, you kind of recognize that internal structure and then use it towards the question. Now, if we had wanted to, we could have also set up the question like this with a corner. And then if I solve that x minus 3 equals 0, I'd get x equals 3, and then do a really quick sign analysis. So at 3, I know I'm going to open up through 3. So I have negative and a positive bit. Using my same kind of colors, I'm going to reflect all these negatives, and I'm going to keep all these positives. And I'll use that format kind of in following questions, so I don't need to do a whole table of values. Okay, so I have one for you. And as we attack this question, I do want you to reflect on the one we just did. So again, you're kind of asking yourself, what stayed the same, what was reflected, and how do you know the sign of f of x? So carry that into this next question. So for you, you're going to try that same question with the inner function y equals negative 2x plus 4, and then flip it to take the absolute value of it. So again, you're going to make a little sketch and then intercepts, domain, range, and corner. So pause it, take a minute and try that question, and then we will take a look. Okay, so here is, try to get on there. So here is this question kind of solved out. So again, you can kind of see up here, I am not going to do a table of values. I'm going to go off with the corner value, just like we've seen with quadratic inequalities. So because this line has a negative slope, the 0 is x equals 2, but the negative slope says that we're kind of dropping from the positive side into it. So I'm actually going to be positive before and then negative after. So positive before means I get to keep that positive side, and the negative after means I'm going to flip that negative side. And you can see that from the graph. So if you look on the right there, you can see over here, I kept everything before the intercept because the original line was going to be positive anyway. And then I needed to reflect where my line was going to go negative. We need to flip it because our absolute value is going to say absolutely not. Flip it over. And that's it. So take a look, and we'll try quadratic next. Okay. Oh, get rid of that. And again, kind of reminder that 0 becomes a corner. Keep the side you want. All right. So quick question for me to do now. Transferring this to quadratic, so moving up a little bit. This one says sketch the graph of y equals absolute value x squared minus 4, and then state all this stuff. Okay, so going a little more quickly through this one. we're going to say, well, let's go after the corners first. So the corners are going to be where that inside function, x squared minus 4 equals 0, right? Because that's where we change from positive to negative. I could solve this question a couple ways. I'll factor it. I could just do it algebraically. But either way, I'm going to get x equals plus and minus 2. So what that tells us is on a number line, at plus and minus 2 is where I'm going to change signs. I look at this thing and I see, well, okay, I have a positive a value, which means I'm going to open up through those points. So I'm going to open up through those points. So what that means is I'm positive on the outside, is negative on the inside. So if I made that sketch, I know my sketch here would look something like this. So here's 1, 2, intercept there, 3, 4. If I put in 3, I'll get 5. So I'll get one more point, 1, 2. So this is what my function, my inner function would look like if there were no absolute value. So if I was just back in the quadratics unit here, so I'd say this is f of x equals x squared minus 4. But the absolute value is going to say, well, this part needs to flip over. So this part on my original curve that was below the axis, I do need to flip that over. I'll label that vertex. We're always interested in the vertex. So what our absolute value function is going to say is anybody down here, any negative output is going to flip, and I'm going to keep the input. The way I like to say that is keep the input, flip the output. So what I'm going to do for that one is 0, negative 4 would become 0, positive 4. So every one of those points flips, and then what that does, if I just kind of connect the dots, I can see it's going to look like that. And then I can kind of connect that piece as well. 1, 2. So in blue there, this is what kind of g of x equals absolute value of f of x is going to look like. So filling in what we have, so the related function, the function we were looking at was that inner function, f of x is x squared minus 4. It had roots at plus and minus 2. We knew it was negative for anything between those two roots, from negative 2 to 2, which is the part that reflects negative 2 to 2. The intercepts and corners, we just kind of said those. Negative 2, 0, 2, 0. And we did also have the y-intercept, 0, negative 4, which is going to flip to a positive 4 on our absolute value. Domain, again, absolute value-wise, was everything. And then range is just y can't be negative. Y can't be negative. There you go. So all done. So I got one more for you to try here. So your question is right here. So sketch a graph of the function y equals absolute value of x minus 1 squared minus 4. State all the things. So again, as you attack this question, you're thinking, what are the roots of the related quadratic? Where are you below the x-axis? And what point will the vertex reflect to? So look at the inner structure. It's a little different here. Pause the video, try the question, and we'll pop back on to quickly discuss the answer. Okay, so here you go. So just kind of popping this up. And again, if you need to pause this, take a look. It's perfect. But you can see we're in vertex form, which gives us the vertex. When I solve for the roots, I'm just going to use the structure given to me, and you can see all the information there. So that's it for this one. I do have a final checklist for you. So with all these questions, what you are doing is you're again just starting with that inner function, right? So this is kind of given the structure g of x equals absolute value of f of x. So start by kind of focusing in on what's happening on the inside. Find the zeros out of the inside function. You're going to use those zeros again as boundaries, as we've discussed. Keep any outputs that are positive. So any inputs that create the positive outputs related to those boundaries. And then any negative outputs you're going to reflect to get them back positive and then state the things. And again, I will write it down. So we're saying keep the input, flip and that's the sign when I say flip of output, if negative. And that's it. Thanks for watching.